Good morning, everyone. How are you guys doing today? I'm so sleepy. Did you guys notice that I posted the review sheet on Brightspace? You did? So the review sheet is based on 7.3 to 10.4. So my plan is to give you next exam from 7.3 to 10.4, but let's see how much you can finish by next Tuesday, and then we'll decide what the exam will be on. Okay, but for now, the plan is on this 7.3 to 10.4, and we are actually done with almost all chapter 7. So we did 7.3, 4, 5, 6. Today we're going to do 7.7 and 8.4. 7.7, 8.4, they are short sections. So most likely we'll be able to finish them today. If we can, then on Thursday we're going to start chapter 10. And chapter 10 is all about radical. So you're going to learn more exponent rules. Not exponent rules, but applying the exponent rules to simplify things. Not this Friday, next Friday. On 11th. Or 11. And today is the last day of dropping any class. So if you're not doing well in any class and you have more than 12 credits, then you're allowed to drop. And if you don't have more than 12 credits, stay and try your best not to fail this class or any class. Any question? Comments? Concern? So in chapter 7, we talked about rational. We learned how to simplify rational, how to find domain, how to multiply them, divide them, add them, subtract them, the real life application. And now we are going to do something called complex fraction. So it's a complex rational. It means we have a rational over a rational, or a fraction over a fraction. So it called complex because it does look complex, right? It looks complex. So normal rational or normal fraction has only one numerator, one denominator. Complex has two numerators, two denominators. And there are two types of complex. One is a single fraction divided by a single fraction. What does that mean? What does that mean? So we have one fraction on the numerator and we are dividing by another fraction on the denominator. So a single fraction on the top divided by single fraction on the bottom. Single. So this is scenario 1. And then we have a second scenario where we don't have a single fraction. We have something like this. Multiple fraction divided by multiple fraction. So depending on what type of complex you have, it can choose different methods. But let me see, how do I keep, oh, here under view. Okay. So if you have a single fraction divided by single fraction, you can do keep change flip, because there's only one fraction on the top and only one fraction on the bottom. So keep, change, flip, and then we write not vertically but horizontally. So we have x squared plus 10x plus 24 x squared plus 13x plus 42. It's the fraction on the numerator, and you're multiplying by fraction on the denominator by its reciprocal. So x squared plus 7x divided by x squared minus 5x minus 36. Again, this method is only for a single fraction divided by a single fraction. So now it becomes a multiplication problem, and we know how to multiply, right? There are 3 steps to multiply rational. What's the first step? Factor. Good job. So now we are going to do factor, cancel, and then rewrite. So let's factor the numerator. Can you think of 2 numbers multiplied to 24 combined to 10? Positive 6, positive 4. Li is at the denominator. Multiply to 42 combined to 13. 7 and 6. How about the sign? Both of them positive. We have 2 terms in the numerator. So which one? GCF or perfect square? Perfect square. You don't have to apply perfect square. The second one is still a perfect square. Is 7x. Do you have a minus a perfect square? So what do you do here to factor? GCF. What is our GCF? X. And what remains? X plus 7. Great. So 2 times means only 2 choices. And then the denominator. 2 numbers multiplied to negative 36, combined to negative 5. Negative 9 and positive 4. So you factored everything, whatever is factorable. Then you go for canceling. Can you cancel anything from the numerator with anything on the denominator? X plus 6. Anything else? X plus 7, X plus 7. X plus 4, X plus 4. And then what remains? X minus 9. That's it. So when they call complex, but actually it's not complex. The first step is the beginning was complex, but once you do keep change flip, it becomes normal multiplication. Any question? Okay, you try one. Ready? Ready? Ronaldo, what's the first step? Keep change flip. So 9 minus x squared over x plus 3. We change the division. And then x squared minus 5x minus 14. 3x minus 3. Anaya, do you know how to factor 9 minus x squared? 9 minus x squared is, let's see, this is 3 squared minus x squared. So it's difference of its squares. 3 plus x, 3 minus x. Not x minus 3, it's 3 minus x. Whatever is the first, we always have to put that first. So 3 plus x, 3 minus x. And we have x plus 3, we keep it. Oliver, can you think of two numbers multiplied to 14 combined to 5? The sign for 2 is positive 2. Camila, 3x minus 3. What can you do? Factor out 3 and you get minus 1. Perfect. Adziri, can you cancel anything from the numerator with anything on the denominator? 3 plus x, x plus 3. They both have plus sign, so it's cancelable. Anything else? That's it? Wow. So Sergio, what is left? 3 minus x. X minus 7. X plus 2. X minus 1. So sometimes we can cancel more, sometimes we can cancel only single term. Interesting. Any question? It always has to be the first term minus and plus the second term. Our first term is 3 squared, so it's 3 plus x, 3 minus x. So when we have single fraction divided by single fraction, we do normal multiplication or normal division, but we do something different when you don't have a single one. Here we have one term, two term, one term, two term. So it's two terms divided by two terms. They are not one term divided by one term. So not one term divided by one term. So don't use keep change flip. Keep change flip is only for one term divided by one term. One fraction divided by one fraction. Here we have two fractions divided by two fractions. So keep change flip is not going to work here. For this, use LCD. LCD method. LCD method. And what is this method? In this method, we're going to find LCD of all the denominators. So we see denominator 1, denominator 2, denominator 3. So if you find LCD of 3, 3x, and 4, what's the LCD among 3, 3x, and 4? So we have only numbers 3 and 4, right? What's the LCD between 3 and 4? Huh? It cannot be 4 because you cannot divide 4 by 3 evenly. Is 4 a multiples of 3? Then when you have two things that are multiple of one another, it's both of them. So you multiply them. 3 times 4, 12. And for variable, what variable you see? So you must keep that. For numbers, if one is not a multiple of another, multiply both of them. For variables, if you have multiple variables, take the highest one. But here you have only one variable, so you take the simple one. Now, once you have your LCD, multiply every numerator. Multiply all the numerators. Every top by LCD. And then cancel, rewrite. Okay. So we have 5 plus 2x over 3, 2 over 3x minus 1 over 4. This is numerator, this is numerator, this is numerator, this is numerator. So you're going to multiply every numerator by the LCD. We have our LCD 12x, multiply here. We have 12x, multiply here. 12x, multiply here. 12x, multiply here. So only the numerator, okay, not the denominator. Multiply only the numerators by LCD and then cancel whatever you cancel. 5 doesn't have any denominator, so it's nothing to cancel. We keep our 5 times 12x. What is 5 times 12x? 60x. And then on the second one, we have 3 on the denominator and 12 on the numerator. We can cancel 3 and 12, right? 3 goes to 12 how many times? 4. So we have 4 on the top. And let's see what remains after that. We had 2x from before. Now we have new 4. And so when you combine all of them, what do you get? 4 times 2 is 8. 8x squared. And then you go to the denominator. So we have 3 and 12, they cancel out. Also this time we have x and x, they cancel out. 3 goes to 12 4 times. So after canceling, we left 2 it. 2 from before and now the 4. So together what do you have? 8. Now on the last one, we have 12x on the top, 4 on the bottom. So you can cancel 4 and 12. 4 goes to 12 how many times? 3. So after the cancellation, we have 1, 3, and x. When you put them together, what do you have? X. So we cancel, we rewrite. And then if it's more factorable, you factor and cancel. And if it's not factorable, you leave it alone. Here we can factor the numerator, right? 60 and 8, they both are even numbers. And x and x squared, it's factorable. So let's factor one more line. 60 and 8, both of these are divisible by which number? The biggest number, which one? They're definitely divisible by 2, right? And also by 4. So you can factor out a 4. And between x and x squared, which one you can factor? X. So you're left to it, 4 goes to 60. 15. Plus 4 goes to 8 twice, so 2x over 8 minus 3x. After factoring, you could not cancel anything, so leave it alone. Sometimes when you factor, you can cancel more. Most of the time you cannot, but it's better to factor anyway. Here, 2x times 4x. 2 times 4, because you multiply with 12x, right? So it cancels only 3 with the 12. But you see over x, you're multiplying 2x by 12x. Now, with the denominator, you can only cancel the 12, not the x. So you still have an x, and after cancellation, you have 4. So from before 3x, now 4 and x. 3 goes to 12 how many times? How is it?
You only do that for the simplest equation. For previous, like for the other LC, you don't have to.
Right. So for single fraction divided by single fraction, you don't need LCD. In factor, cancel with that. But here you see we have plus and minus 2 terms, more than one thing. So for more than one term divided by more than one term, take the LCD for every denominator. And then if you multiply all the numerators, you like this easy. There are other ways of doing it, but I like this one because this is much simpler. You can solve it only 2 lines. This is extra. Let's do one more together. They look very similar, but they're not same. Oh, and I forgot to tell you, one of these will be in the final. Complex. And mostly they give this type, not a single divided by single one. So this time we have all the denominators x, 3, and 6. What's the LCD between among x, 3, and 6? 6, 6x. Between 3 and 6, 6 is the multiples of 3. So from this we get 6. And in the variable x alone, so it's 6 with the variable x. And then what do we do with this LCD? Multiply only the numerators. So 6x, 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 and 6x. The purpose behind multiplying the numerator is to cancel the individual denominators. So 5 doesn't have any denominator. We are safe. We only multiply 5 and 6x. What do we have? 30x. Now on the second term, we have x on the denominator, x on the numerator. We cancel. Then what is left on the numerator? 2 and 6, 12. First term on the denominator, what do we cancel? 3 and 6. 3 goes to 6, how many times? Twice. So what is left after the cancellation? 2x squared. 2x squared. And lastly, on the last denominator, we only cancel 6. What remains? 5x. Technically, we are done, but we do one more step just in case if we can cancel more. So we go for factoring. What can we factor on the numerator? 6. And we left with 5x plus 2. What can we factor from the denominator? And we left with 2x minus 5. They look similar, but actually they are not same. So you cannot cancel. We'll leave them alone. But sometimes after the cancellation, we can cancel. That's how you factor. But in the final exam, if you see this already, stop here. You don't have to factor anymore. So how do you feel about this? Hard, complicated? One more? Yeah, I have one more, the last one. They are not same, so you cannot cancel them. If it was 2x plus 5 and 5 minus 3x, we could cancel because they're same with opposite sign. But here they're different. But the next one is much easier. See the way I indicated what is left after the cancellation? You also should try that. You know, in that way, you'll see what is left and you will not forget about any of the variable or number. So circle what is left after you cancel. In here, I highlighted them. Going to that and next slide, it's a good slide. Today is April Fool Day. Oh wow. Okay. Janisha, Eliza here, Fabricio, nope. Sergio here, Miley here, Oliver here, Himadri here, Mustafa here, Jacqueline, Jain here, Anaya here, Jason absent, Atsiri here. Anthony disappeared. Joseph here. Sitlali here. Saida here. Muhammad finally showed up. Ronaldo here. Daniel here. Jeremiah absent. Camila here. Julia here. Jasim absent. Are you guys ready? Fabric, I just took the attendance. So we are looking for LCD. What is the denominator this time? Or what are the denominators this time? X and X square. Mustafa, what's the LCD between X and X square? X square. So 4 over X minus 1, 3 plus 2 over X squared. What do we do with this LCD? Multiply all the numerators. Okay, Helene, what happens then? We have 4x squared divided by x. Can you cancel anything? We can cancel x with the x squared. What is left? You have x squared divided by x. After the cancellation, what is left? X is left. Remember the rule in division, what do we do with the powers? Subtract. So you have 2 minus 1, which is 1 power. So we get x left. So we have 4 and x on the numerator. 4x. 1x squared is just x squared. We'll leave it alone. 3x squared is also x, single thing. We'll leave it alone. Himadi, what happens in the last denominator? We cancel x squared and x squared. We left to it only the 2. So technically you're done, but you can stop. We go for one more step. What do you do next, Sitlali? What do you observe in front of you? We have 4x minus x squared. Good, we go for factoring. When you factor x, what do you have? Great. Mustafa, can you do anything on the denominator? So we'll leave it alone. And that's all you have to do. Find LCD of all the denominators, multiply all the numerators, cancel, rewrite.
So for the 4x times x squared, why didn't you just leave the square? If we're just canceling the x, or is it anymore?
Because square is not anything. It's x times x. So x squared means it's x times x, and you're dividing by x. So when you cancel, what is left? Not a 2, it's x left. So if you forget your exponent rules, no problem. Write out what does x squared means, what does x cubed means, what is x to the 4 means. So write your x that many times, and then you can see what is left after the cancellation. With this, you're done with 7.7. So we are officially done with chapter 7. Now we are going to chapter 8. From chapter 8, we are going to do only one section. 8.4. It's called variation. If the writing is bloody, forget, ignore them. I'm going to tell you what I wrote there. So variation means how two things are related. And we have two types of variation in our life. Either two things that are directly related, if they have a relation, or they're inversely related if they have a relation. For example, number of hours versus your paycheck. What do you think the relation is? Direct or opposite? The more hours you work, do you get the more money or do you get the less money? More money. So you see, both of them are increasing. The more you work, the more you earn. So your number of hours, working hours, and the amount of money you have, they have a direct relation. It means when one thing is increasing, the other thing is also increasing. When one thing is decreasing, the other thing is also decreasing. So they have a direct connection, a direct relation. They call them a direct variation. And to represent the direct variation, we use a straight formula. Let's say X and Y, they are directly related. So we can express this as Y equals KX or X equals YX. Sorry, my bad. X equals KY. Okay? It means X and Y, they're increasing with the same constant K. If X is going up, Y is also going up by a factor of K. If X is going down, Y is also going down by a factor of K. So the number of hours and how much you earn, they have a factor, it's called pay rate. K in your real life for money problem is the pay rate. So what is the pay rate? $17 per hour. So that K represents $17 per hour. So you are increasing by a common factor. Now, another example. The faster you drive, the less time it takes you to reach your destination. True, right? The faster you drive, the less time it takes. So your speed versus time, do they have direct relation or inverse relation? Inverse. See, you're going faster, means your speed is increasing, but your time is decreasing. The more fast you drive, the less time it takes. So they have an inverse relation. To represent inverse relation, we use reciprocal. So if X and Y are inversely related, we say Y is changing by a factor of K, but is changing inversely with the X. Or we say the other way around. X is changing inversely with Y. So inverse, which is a fraction, direct, which is direct. Okay. So these are the two types only we have. If two variables are connected anyhow, if two things are related somehow. Now, based on this concept, we are going to do some examples. For example, let's start with something easy. You write an equation to describe the variation. Use K for the constant of proportionality. That K, it has a special name. We call it constant of proportionality. Constant of proportionality is K. So they are saying write an equation for the two scenarios they give you and use K for your constant rate. R varies inversely as dq. So you write the equation based on what is written in the sentence. The sentence started with R, so the equation must have to start with R. Now varies means the evaluation. So R is changing. Varies means it's changing. R is changing inversely. What does inversely mean? The first equation or the second equation? Second one. So we have equals a fraction. So R is changing inversely as dq. Whatever you have here, that always goes to the denominator. So d cube goes on the denominator. And how R and d cube are changing? With a constant rate k, which we don't know. So the constant rate always goes either in front or on the top of your second variable. Okay? So rewrite exactly as it's written. Now for the second one, it says R varies directly. So how do you write this equation? Any volunteer? Mustafa. Good job. K times dq. So direct means they're on the same level. So R and dq, they're on the same level on the numerator, and they are changing with a constant rate here. Any question?
It's
Times. So the first scenario, we derived equation. In the second scenario, after deriving the scenario, so after deriving an equation, now at least find out what is the constant rate. What's the k? What's the value for k? So here they're saying y varies directly as x. Find the constant of variation means what is k. Also write the direct variation equation. So let's start with our scenario. Which variable is written first? X or Y? Y. Y is changing how? Directly or inversely? Directly. With which one? With what variable? So directly means they're on the same level. So Y equals X, but they're changing with some type of rate K. So step one, rewrite the information in mathematical notation. And now you cannot stop here because they're telling us, hey, find what is K. What is that? In order to find that, they gave us X value and the Y value. So we substitute. What is Y? What is X? 15. We don't know what is K, so we leave the K alone because we don't know how much that is. But now we can solve for K. If you want to solve for K, which one you have to get rid of? The 15 or the 5? 5 is on the other side of the K. Does it affect K? We don't want the 15 next to the K because we want to get the K alone. So you divide by 15. Now you have your K's alone. And what is 5 divided by 15? Can you reduce that? Both 5 and 15 divisible by which number? So if you divide them by 5, what do you have? 1/3. 5 divided by 5 is 1. 15 divided by 5 is 3. So 1/3. So this is the answer for A. What is your value for K? Oh, X and Y, they're changing directly with a factor of 1/3. And now B says, well, once you know your factor, now write your equation again by replacing your constants. So for B, you write Y equals Kx again. But this time we know what is K. So we replace our K with 1/3. So for any type of variation question, we are going to do this. This is our first step. Always start with the equation based on the given information. Find what is your K. Once you know your K, then rewrite the equation by replacing your K. This should be your steps for every question you see from now on. And then you're going to do more based on the information they give you. For now, based on the information 5 and 15, that's all we can have. Any question? Now let's see what they want us to find more. This time they're saying y is changing inversely with the square root of x. And when x is 4, y is 7, they know that somehow. But they would like to know, well, what if when x is 9? If x is 9, then what should be the y? So they want us to find more than what we have done in the second question. So we are going to write an equation based on the information here. And this is a final exam question. You'll have at least one from 8.4. Danielle, would you like to try this one? Which two things are changing? So you don't want to help me, no problem. Fabricio, would you like to help me with this? First question, which two things are changing? One thing is y, right? And what is other thing? Only x? Inverse is the relation, but is only the x changing? Something else is with x. Which two things are changing? We can see one of them is y. What's the other one? Ronaldo? Out loud? Square root of x, not x, square root of x. So y and square root of x, they're changing. How they're changing? Directly or inversely? Inversely. That means if y is on the front, y is on the top, square root of x must be on the bottom. Not x, square root of x. So y and square root of x, they are changing inversely. So y is on the top, square root of x on the bottom. Then what goes on the top of the square root of x? The constant, the rate. At which rate they're changing. That's how we figure out the equation. We started our sentence with y. That means our equation must start with y. However, you are starting your sentence for the variation, your first variable always should be that. So y varies means y is changing. It means y equals. Now y is changing inversely means we have a fraction on the other side of the equal sign. Now what else is changing with y? Is the square root of x. So on the denominator is square root of x, and numerator we have the constant rate. At which rate these two functions are changing. Now, just like the previous one, first step is always find k. Second step, rewrite your equation. That should be always for every question. So how do we find x? So how do we find k? Do we have information for x and y? What's the y? And what's the x? 4. So we have y equals k over square root of 4. What is square root of 4? Square root 2. 4 square is 16, but it's square root. Root makes everything smaller. Okay, our goal is to get the k alone. So what is our problem here? The 7 or the 2? 2. How do you get rid of the 2? Multiply. It's only dividing here. So if you more divide, you get more bigger number. So you don't want bigger number. You want to get rid of that 2. So you multiply by 2 both sides. So what is our k? 14. So we complete our step 1. We found our constant rate. What is our next step? We rewrite in the equation. So our equation is y equals k. Instead of k, we write 14 over square root of x. So step 1 is always find k. Step 2, rewrite by replacing your k. Rewrite the equation. And then we see, do we have to go further? We can stop here. They have one more sentence we did not use. Point x is 9. What is y? So now what do you do?
So substitute the x with 9 and the square root of 3. So
perfect. With the second information where our x is 9 and we get 14 over 3 and we stop. So based on what information we have, we stop at a different level. For the left one, we stop after writing the equation because they didn't ask us to do anything else. They didn't give us any more information. But here we have to go further because they gave us one more information that we need to use. So we used here. So let me highlight it yellow. This portion is the yellow portion here. And yes, in the final exam, they'll give you something like this. But you have to do all 3 steps. Step 1, find k. Step 2, rewrite your equation. And step 3, find a variable when another variable is given. Any question? Let's see what we have next. Try this. always ask yourself, what or which two things are changing? Oh. Ready? Joseph, what two things are changing? It's written in the first sentence. Good. How they are changing? Directly. So what equation we get from here? Only x? X squared. Good job. Step one, figure out what two things are changing and how they're changing. So y and x square is changing, not x. Y and x square is changing directly, means k times x square. Mustafa. So what is y? 5. We don't know k, but what is x? 2 square. So we have 5 equals k times what? 4. And then what do? We divide by 4. So 4 cancel out. We get k is 5/4. Miley, what do you do from there? Good. So we have 5/4 times x squared. So we rewrote the equation. Do we stop here? No, because they gave us more information. What do we do with this information? Sajja. Is so 5/4. Our x is 3 squared. And what is c squared? 9. And then what do you get from here? Below 9, what do we have? So when you multiply 5/4 times 9/1, what do you get? How do you multiply fraction and unfraction? Across. So 5 times 9, 45 over 4. What do you think about this? Easy, hard, confusing, doable? Okay, great. So we've seen what happens when they are related inversely, what happens when they are related directly, and now a weird situation. What if they have a double relation with double functions? Two types of relation with two different types of function. This is called joint variation. Joint variation. So three functions are changing at the same time with a constant rate. Write the question down and then we're going to do it. So what are changing? First, what do you notice? Which two things are changing? Y and Z, okay. How Y and Z are changing? Directly or inversely? Directly. So what formula we get from here? If Z is changing directly, what should go on the right side of the equal sign? Only Z? No. KZ. So Z and Y, they are changing directly, so it's Y equals KZ. And now at the same time, what else is changing? X squared. How is changing, directly or inversely? Inversely. So inversely means a fraction or on the same level. So you write a fraction and you write, oh, not square root, sorry, square. See, that's how we get one equation from two types of change. Z is changing directly, so it's k times Z, but x squared is changing inversely, so it's k over x squared. But we have only one k because they are changing at the same time. They're not changing differently. They are changing at the same time with the same constant rate. So k must be once, and we have two different functions. One is directly, one is inversely. So that's the difference between the previous two examples we did and the joint distribution. In joint distribution, we have numerator as well as the denominator. And then we do the same thing what we did before. Our goal is to do what next? Solve for k. So you plug in. What information we have for y? 5. We don't know our k, so you leave it alone. What is our z? 3. What is our x? 2. So we have 5 equals k times 3 over 4. Now, if you don't want your 3, how do you get rid of the 3? By multiplying or dividing? But 3 is already multiplying with k. If you multiply more, does the problem get solved? So 3 is multiplying with the k. So in order to get rid of the 3, what do you have to do? Not subtract. What is the opposite of multiplication? Division. So I need to divide by 3 so they cancel out. And you're only dividing by 4. So in order to cancel this 4, are you going to multiply or divide by a 4? Multiply. So 4 cancel out. To get rid of anything from the numerator, you put it on the denominator. To get rid of anything on the denominator, you put it on the numerator. So you need to multiply by reciprocal of E4, which is 4 over 3. That means you also have to multiply 4 over 3 on the left side. So based on the right side, it decides what you have to multiply and divide by, and put the exact same thing on the other side. So now we have our k alone because 3 cancel out, 4 cancel out. And what is k then? What do on the other side? 20 over 3. What is our next step? We rewrite. So y equals, instead of kz over x squared, we write 3 x squared. But it does look complicated, right? So instead of writing it this way, we can actually rewrite as y equals 20 on the top, 3 on the denominator. And if z on the top, you can bring this 3 next to the x squared because 3 is a denominator. So you can put 3 and x squared as one denominator and 20 and z as one numerator. You're allowed to do so in a fraction. And now it looks much nicer, cleaner, right? It's not horrible looking like this. You don't have to do it, but if you do it, your life is easy. Now what do you do? Plug in the new number. What is the z? So we have M3 squared we replace X and Z. And we got 20 times 2, and then 3 times 9. What is 20 times 2? 40. And 3 times 9? 27. If you did not bring the 3 down, that means you have to work with a fraction divided by fraction. The life will be harder. So anytime you have a fraction in a fraction, you can always you can combine the denominators together and numerators together. We have one more question left, but we're going to do it in our last class to refresh your memory with the variation. And then you'll be done at 8.4, 8.4 or 8.3, whatever. 8.4. So on Thursday, we are going to do 10.1. One question from 8.4 and then 10.1. I was supposed to give you the reflection. I have my reflection, but I forgot to give it to you.